Descriptive Statistics, Part 3. In the previous chapter, we talked about crosstabs and scatterplots to describe the relationship between two variables. However, the drawback of those two methods is that they do not tell us the strength of the relationship between the two variables. The covariance measures the strength of a relationship between two variables. I want you to notice that the covariance is really a variance between two variables. You can easily see the covariance of two identical variables is the variance of that variable. So if we were to replace here x with y, we would have xi minus x bar, which would give us xi minus x bar squared, which is exactly the formula that we have for the variance of x. The covariance tells us how x and y move together. If the covariance is positive, we say the two variables are positively correlated. If the covariance is negative, then we say the variables are negatively correlated. If the covariance is 0, then the two variables are independent from one another. The coefficient of correlation is an improvement on the covariance in that its units are independent and is bounded between -1 and +1. If the two variables are perfectly correlated with one another, then they form a straight line. If the correlation is negative, then the correlation coefficient is -1. If the correlation is positive, then the correlation coefficient is +1. And if the correlation is 0, then the two variables are independent. For the population correlation value, we use the symbol rho. And for the sample, we use the letter R. It has the following features. It's unit-free, and it ranges from -1 to +1. Anything that's positive is going to be a positive correlation, and anything that's negative is going to be a negative correlation. Here are a couple examples of coefficients of correlation. Here we can see a fairly straight negative line between y and x. And this is pretty close to a straight line. The correlation coefficient is pretty close to -1. Here we see again a negative relationship, but there's still some more variation between y and x. In other words, the relationship isn't as strong. So we still see a negative correlation estimate, but it's not as close to -1 as our first example was. Here is nearly a straight positive line between y and x. That is, as x increases, so does y, and it's almost a straight line. Thus, we have a very strong correlation, very close to +1. We can weaken that, and if we do weaken it, meaning that the data are scattered around even more, we see that r is positive, but it's not as correlated. In other words, it's further from 1 and actually closer to 0. And in the case where our correlation coefficient is exactly 0, we see that there is almost no relationship between y and x. We can use the data analysis toolpack to conduct correlation calculations as well. When we open up the data analysis tab, we want to select correlation. Then we highlight the two variables we want to know the correlation between and press OK. The output is a matrix that tells us the correlation coefficient between each variable. The correlation between the same variable on itself is always 1. You could bypass the pull-down window and just use the covariance and correlation commands in Excel. The population covariance is going to be COVAR and then the two variables, and the sample correlation is just coral and then those two variables. Notice that the correlation coefficient and the covariance always have the same sign. Some pitfalls in numerical descriptive statistics. Data analysis is objective. should report the measures that best describe and communicate the important aspects of the dataset, that is, the central tendency, the variation, and the shape. Should document both good and bad results. Ethical considerations should be done in fair, neutral, and clean manner. That is, you have to say everything you did. Should not deliberately use inappropriate summary measures to distort the facts. In summary, in this entire chapter, we described mean, median, and mode. That was our first video. We described the measures of variation, our second video. We even showed some illustrations of shapes of distributions and a box plot. That is the 5-number summary. We just talked about a little bit over covariance and correlation. We'll use those quite a lot towards the very end of class. And we addressed pitfalls in numerical descriptive measures and ethical considerations. Now you can move on to the next chapter.